This is a question from databases. Let R be a relation having the attributes A, B, C, D, be a relational schema with the following functional dependencies. A determines B determines C determines D determines B. The decomposition of R into three relations, that is AB, BC and BD, and four options are given. So we are asked to find out the decomposition of this particular relation is lossless or lossy, as less dependency preserving or not dependency preserving. So first let's understand what is lossless join. Lossless join. Lossless join. So the decomposition of a relation R into two parts, that is R1 and R2, is said to be lossless decomposition if at least one of the following functional dependencies are in F closure. That is R1 intersection R2 determines R1, or R1 intersection R2 determines R2. This is the basic concept of lossless join. Second one is dependency preserving decomposition. So decomposing the relation R into R1 and R2 is a dependency preserving decomposition if closure of functional dependencies after decomposition is same as closure of functional dependencies before decomposition. So closure of functional dependencies before decomposition is equal to closure of functional dependencies after decomposition. So this is the basic concept. A simple way to check whether we can derive all the original functional dependencies from the functional dependencies after decomposition can determine whether the decomposition is dependency preserving or not dependency preserving. So let's try to solve this based on this concept. So let's write the relation as A, B, C, D are the attributes. Now we are decomposing it into three, that is AB, BC and BD. Then the attributes or the dependencies includes A determines B determines C determines D, and D determines B. These are the functional dependencies. First, let's try to see if it is lossless or lossy. So first decomposition A comma B and B comma C. So the first way to identify is that if you perform a natural join in this, then it should preserve all the dependencies here. So the major thing to find is, first we have to find a common attribute. Here B is common attribute, B is common, and B is a key in the dependency B determines C based on this functional dependency. So B is primary key also. B is key also in B determines C. So performing natural join, we will get A comma B comma C. This is one, and all the dependencies are preserved, or all the dependencies can be captured. Now A, B, C with next one is B, D, B comma D. Here also B is common key here, as also B is key for B determines D. So performing natural join, we'll get A, B, C, D itself. So this is lossless join. Lossless join. This is the first part. Now we can see if it is whether dependency preserving or not dependency preserving. So the decomposition is dependency preserving, as the dependencies are preserved because we are having A determines B is captured in the relation A comma B, in the relational table A comma B. Then B determines C is captured in the relation table B C. Then D determines B is captured in BD. Then finally we can also capture C determines D based on indirect dependency preserving in BC. So it is dependency preserving. Dependency preserving. So the 2 points to highlight is this is lossless as well as dependency preserving. Now let's see what are the options. So it is lossless as well as dependency preserving. So option A, it gives a lossless join and is dependency preserving is the correct answer. Option A is the right choice.